Hello everyone, welcome back to the channel. If you're running stateful applications and need reliable, production-grade persistent storage that's simple to deploy and manage without dependency on external storage provider, Longhorn is the solution. Let us understand how Longhorn works. Longhorn runs entirely within your cluster, turning ordinary storage nodes into highly available, self-healing storage solution. Longhorn consists of several microservices, CSI driver, which bridges Longhorn and the Kubernetes storage framework. We have Longhorn manager, runs on every node, orchestrates and manages all the volumes. Next, we have Longhorn engine, a dedicated microservice per volume, which coordinates data writes and reads in the cluster. Next, we have replicas. Each engine synchronizes data to multiple replicas distributed across different nodes for fault tolerance. So when you create a persistent volume claim or PVC, Longhorn provisions a volume, creates an engine, places replicas across your cluster. If a node fails, as long as at least one replica is healthy, your workload stays up. That's resilience by design. Longhorn can be installed on Kubernetes cluster in several ways, and we are going to use Helm. As a prerequisite, ensure OpenISCSI and NFS Common are installed on all worker nodes. In production environment, it is recommended to have dedicated storage nodes. I have listed all the requirements in the detailed blog post, which will be linked in the description below. So I have already logged into the worker nodes. I have 3 worker nodes, and I have 3 additional disks attached with 40 gig each. So let's go ahead and install the NFS Common and OpenISCSI on all the nodes. So we are installing the NFS Common, OpenISCSI, then we're enabling the iSCSI service and checking the status. Okay, that's done. Longhorn provides an environment check script, which we can run to ensure all the prerequisites are in place before we can start the installation process. So I'm downloading the Longhorn CTL. Okay, let's make it executable by running chmod +x longhorn CTL. Then we're going to run longhorn CTL check pre-flight, then the kubeconfig file, which is in the location .kube/config. Okay, so it says the Longhorn system is not found. Let's quickly go ahead and create kubectl create namespace, and we're going to call it Longhorn-system. Enter, and let's run the script again. Okay, that completed. As we can see, we have the NFS Common installed, OpenSCSI is installed, and all the required packages are installed. We don't see any errors. We just have some warnings which we can ignore. Great. So let's proceed. Next, we're going to add the repo. So we're going to add elm repo add Longhorn. Then we're going to do elm repo update. Once done, we're going to do helm fetch to download the charts locally, so that we can make changes and keep it locally, so that in the future, if you want to reinstall Longhorn with the older version or with our changes, we can use the same files. So it has downloaded. Let's go to Longhorn, and I'm going to open the values.yaml file. Here you can go ahead and make changes based on your requirement. There are different Longhorn components, which, as we learned earlier, we have Longhorn engine, and the tag is 1.10.0, which is the version we are going to install in our cluster. If you scroll down, you can make changes based on your requirement. For example, the UI can be accessed using a node port or load balancer, which you can change here, the type. And by default, the number of replicas count is 3, and you can change it based on your requirement. So there are a lot of options which you can take a look and change it based on your requirement. Let's close this. Let's go ahead and install Longhorn. So I'm going to run helm install Longhorn. We're going to call Longhorn. Then the values file, okay, is values.yaml. So we are inside the directory, so I'm going to make it values.yaml, and the namespace is already created. We can remove or we can keep it the way it is, and we're going to hardcode the version which is 1.10.0. Let's hit enter. Okay, so it's deployed in the Longhorn system. Let's go ahead and do kubectl get pods -n Longhorn system. So let's watch them. Okay, as we can see, all the components are up and running. So it approximately took 7 minutes for me for all the pods to be up and running. You might have seen a few pods are in errors or in crash loopback. Don't worry about it, let them run. So they generally come up without any issue. Let's access the Longhorn UI. kubectl get svc -n Longhorn system. We can access the UI using Longhorn frontend service. Since the service type is cluster IP, we're gonna use port forward to access it. kubectl port forward svc Longhorn frontend, then the local port 8080 to 80, then the namespace Longhorn system. So now we can access it using 127.0.0.1:8080 is the loopback address. Let's copy this, go to a browser, paste it. There you go. That's our Longhorn UI. So this is not the ideal solution. So what we're going to do is we're going to expose our Longhorn UI using Ingress and configure a basic authentication so that when somebody wants to access the UI, they will be prompted with username and password. Let me cancel, clear the screen. Let me go ahead and create a basic auth using this command, which allow you to create a user and a password. I'm going to call my user as Longhorn, and I'm going to specify the password as password. Let's create this. Let's check the auth file. So it has created a user called Longhorn, and this is the password. Next, we need to create the secret, and we're going to create a secret called basic auth using the file auth. Let's run this. Okay, so it's already exists in my case, so we can proceed with the next step of creating the Ingress resource. I have already deployed Nginx Ingress controller in my cluster. Let me check kubectl get pods -n Ingress Nginx. So it's up and running. So I'm going to create an Ingress resource called Longhorn frontend in the Longhorn system namespace. Ensure you have the following annotations in place. The auth type is basic, the auth secret is basic auth, and the auth realm is authentication required. I'm using a custom domain to map my Longhorn UI to longhorn.mkbn.in. Let me create this. If you don't have a custom domain, you can always use the port forward to access it, or if you have a load balancer in your cluster deployed, then you can use the load balancer IP to access. But if you want to access via custom domain like I'm doing now, you can basically create an A record in your domain registrar with the ingress IP. So let's go to kubectl get svc -n ingress nginx. So you need to map this IP, the external IP for the ingress nginx controller, to the domain, which is longhorn.mkbn.in in my case. Okay, let me do kubectl get ingress -n longhorn system. So we have the ingress resource deployed successfully, and we can access using this particular host. Let me copy this and go back. Let's close this. I'm going to say https://longhorn.mkbn.in. Okay, it's prompting for us to enter the username and the password. Let me enter. And as you can see, we are able to access using our domain, and it did prompt us for the username and the password. So when we look at the UI, we have the volume, then we have which gives information about the storage and the number of nodes we have. We currently have 3 nodes, which are schedulable, and we have 98.3 gigs of storage available for us to use in the cluster. If I go to the node section, you can see these are the 3 nodes. Let's assume you have additional storage devices in your worker nodes. If you want to map them, it's very simple. You can just click on this line and click on edit nodes and task, come all the way down, click on add disk, and you can just basically add the path and click on enable and save, and that will add the disk. In our case, we're not going to do that because we have a single disk which are already mapped. Let's go ahead and deploy a simple demo stateful application to test the Longhorn's snapshot and backup feature. I have the YAML file called git.tia.demo, which deploys a git tia stateful application. You can take a look. I have creating a persistent volume claim, then we have a deployment with a single replica, and we have a service which will be exposing the application using load balancer. Let me copy this, and we're going to create a simple YAML called git.tia.yaml. Let me paste it here and save. We're going to create it using kubectl create -f git.tia.yaml. It created the namespace called git.tia.demo, then a secret, a config map, a PVC, a deployment, and a service. If we go back to our Longhorn dashboard, we can see we have a volume created, which is in the namespace git.tia.demo. Let's go inside, and it has 3 replicas, and it's healthy and it's ready for workloads. Let's go back and run kubectl get pvc in the namespace git.tia.demo. So we have a PVC. Okay, let me close this, maximize. Okay, that's good. All right, let's get kubectl get svc and git.tia.demo. We can access the git.tia using the external IP and port 3000. So we open another browser, :3000. Okay, so that's the welcome page. We're going to sign in with our default password, username admin, and password change me 123. Bang. Sign in. So let's go ahead and create a repository. We're going to call this Longhorn, and I'm not going to add anything else. Maybe we can initialize a README and create the repository. So we have created a repository. Let's make some changes. For example, it has a readme called Longhorn. We can just say Longhorn deployment and commit changes. Okay. Now we have something to test. So let's go back to Longhorn. And the first thing what we're going to do is we're going to take a snapshot. You just have to go back to the volume, select the volume which you want to take a snapshot, and click on take snapshot. This will go ahead and take a snapshot. It might take a minute or so based on the size of the data. So let's scroll down. You can even check the event logs, or you can also expand the snapshot and backup list, and you can see the snapshot we have took a few seconds ago. Right, that's good. So what we're going to do is we're going to simulate a failure, like somebody accidentally deleted this readme.md, or maybe they just accidentally removed the content of this file. Let's do that. Let me go ahead and commit the changes. So we currently do not have the readme, right, with the content. So how do we restore the previous deleted data using the snapshot? So we have took the snapshot when the data was available. So what we're going to do is let's go back, and if you see we have a deployment in the git here demo namespace. So we're going to scale this down to 0, kubectl scale deployment, and we set the replicas to 0. Okay, and if we check deploy, so we don't have any pods. It's currently 0/0. Okay, so as you can see now, even the PVC is detached because we don't have the pod running. Okay, next what we're going to do is, let me refresh. What we're going to do is we're going to attach this volume. You can choose any one of the node in the maintenance mode. Click on OK. So it is attaching, and it is attached. And if you go back, now we can see the snapshot and the volume head. This is the actual data. So we're going to click on the snapshot, click on revert, and say OK. This will take maybe a minute or so. So just be patient. Once this is done, what we have to do is, you can see it says healthy. So we just need to detach the volume again. So let's go here, and we're going to detach the volume. Click on OK. So it is detached now. And we're going to scale up our deployment back to 1. If you see now kubectl get pods, then we should have demo app coming any seconds now. Yes, the pod is running. Let's go back, and we can see the PVC, which is healthy, ready, and it is scheduled. So let's go back and let's refresh. And as we can see, we have the content back in our Git repository. That's great. So we were able to restore from the snapshot. Now let us see how we can back up the entire volume in case we want to restore. For example, if somebody deletes the application accidentally or something happens, then we can go back to it. The interesting, if you can see, currently the create backup target is the create backup is grayed out because there is no target defined. So what we're going to do is we're going to go to the backup targets. We don't have any. I have an NFS server which we can use to back up our volumes. If you have any S3 compatible solution, you can use it. So I have an NFS, so I'm going to configure that. I click on default, and it is 101, and this is my NFS server IP, and I have a directory called /mnt Longhorn. So that is where I'm going to save all my backups to. I click on OK. and the status is available. That means we should be able to take the backup now. Let's go to volumes, then go back into the volume, and we can see now we have the create backup available. So let me click on create backup, and I'm going to take a full backup. Click on OK, and let us give it a minute or two so that it backups the data and copies to our NFS server. Okay, you can already see we have a backup created a few seconds ago. Let us wait for a few more seconds. Okay, so that's done. And this is the backup. How do you identify? When you hover over on the icon, and if you can see the backup is backup, right? And for the snapshot, you will not have that information. Also, what you can do is you can just click on the backup and restore, go to the backups, and you should be able to see your new backup. Okay, that's great. So we have a backup which is copied to our NFS. So what we're going to do is we're going to simulate a failure. Let's assume somebody accidentally deleted our stateful application. Let's do that. Go to kubectl delete -f gittia.yaml. So it basically deletes everything from the namespace to the PVCs, the deployments, and everything. Okay, if we do kubectl get pods, we don't have anything. If we do kubectl get PVC, and we should not have anything. Okay, and also if you go back to the Longhorn, we don't have any volumes. It is completely wiped out, and you will not be able to access the UI anymore. Okay, so what we're going to do is let us restore from the backup, which we have took a couple of minutes ago. Let's go back to the backups. So we do have a volume backup. Select that. Then we're going to click on restore lost backup. So I'm going to call this git tia restore data restore. You can call it anything, or maybe, for example, if you want to use the previous name, you can use that. That is pretty neat. It will give you the same PVC name, but I would like to specify it as a restore so that I know this is restored from a backup. So I'm not going to change anything. The number of replicas stays 3. Then the engine is v1, and I'm going to click on OK. Now, if you go back to the volume, you see we have a git tia data restore volume, which shows healthy, but it will be detaching again, and it should not be registered. Okay, that's good. Now, what we need to do is we need to create a PVC from this volume. You can click on these 3 lines on the right, and you have an option to create a PV or PVC. So currently we don't have the namespace, because when you delete, it basically deletes the namespace. So let's go ahead and create a namespace. kubectl create namespace git tia demo. So we have created the namespace, and if you go to kubectl get PVC, so we currently don't have any PVCs. So let's create this, and we're going to use the previous PVC, which is called git tia data. If you want to call something else, you have to modify your YAML manifest and match to the PVC name, but I'm going to keep it git tia data, then click on OK. This should create a PVC, and if we run again, so we have the PVC. Okay, that's good. Now let's head back. How do we restore? So we have the manifest. What we have to do is, in the persistent volume, you need to add a new parameter called volume name, and I think we call git tia data restore, if I'm not wrong. Git tia data restore, yes. So ensure that you have the name, whatever the name you have created. Then rest should remains the same, because we did not change the name of the PVC. We kept it git tia data, so we should be good. Let's go back, git tia.yaml, and let me scroll up. In the PVC, I'm gonna just uncomment this line. Let's save this. And we're going to create kubectl create -f git.yaml. Yeah, it will throw that the namespace is already exist and the PVC is already exist. That is fine. We know that we have created both. And let's check kubectl get pods -n git demo. It is up and running. Let's go back and see the volume is attached and healthy. And we should be able to access. Yes, we are able to access. If I sign in again with admin, sign in, and we have the repository and we have the data as well. Right, that's great. So we have successfully restored our application from the backup. And the next thing what we're gonna look at is how do we create the snapshot or the backups on a regular interval, right? So we don't want to manually create the backups. So Longhorn give you a pretty neat feature where you can create the jobs, like cron jobs or recurring jobs. You can just click on create recurring job, and maybe you can call this whatever the name. For example, this is a Gittia app, so I'm going to call Gittia. Then you can create the cron. This is the regular cron expression. Based on your requirement, you can modify. For example, if you want to take a snapshot like once in every hour, or if you want to backup every day, you can do that. Then click on OK. What this does is it basically takes a snapshot. Similarly, for example, if you want to create a backup, you can go git tia. Then instead of snapshot, you can say git tia backup, and maybe you can just change it to a backup. If you want to define some labels and groups, you can do that and click on OK. So it creates the backup and snapshots every day in this interval. Great. That's a wrap. With Longhorn, you get enterprise grade storage, which is highly available, self-healing, simple to manage, and integrate with Kubernetes. If you found this video useful, please like, subscribe, and hit the notification bell for more Kubernetes and DevOps tutorial. Thanks for watching.